EUB Reddy, Uday Bhaskar Reddy from Andhra University, an environmental science professor, and he's been here on September 5th, I think. Then also he spoke, he was a keynote addressee then on a subject called environment. So today, on our request, again, he has come here to speak on a very important subject, nanotechnology, thrills and threats. How nanotechnology is going to dominate our lives tomorrow. And Professor Uday Bhaskar Reddy, with his vast knowledge, on the subject environmental and with nanotechnology, he will enlighten us with his knowledge and tell us about how the future is going to be on this new technology called the nanotechnology. Nano is, again, it is called the small particles. And how small particles, when we talk about nano atoms and all these things, I think he will tell us today. And before, I don't want to take much of your time. I request Dr. James to introduce the subject and also introduce Professor Reddy to the audience, and later Dr. Aputota Srinivasulu will moderate. From there, Dr. Reddy will speak on the subject. Thank you so much.
Good evening. I welcome everyone for the 435th session of Telangana Jana Vedik. Our topic today is thrills and threats from nanotechnology. The generic name given to the production or use of very small or nanoparticles is nanotechnology. These are particles that are less than 1,000th the width of a human hair. According to the National Institute of Advanced Industrial Science and Technology, Japan, nanotechnology is technology to manipulate and control a substance at the nanometer, nm level. So 1 nm is equal to 1 billionth of a meter. We know that the nanometer level is the level of atoms and molecules. This new technology can help create new materials and devices with many functions, making the best use of the special properties of nano-sized substances. For example, in today's industry has its limits in miniaturizing components. But a completely new approach using nanotechnology can be helpful to produce components and systems with nanometer level precision. This has tremendous implications for devices as they will be able to store information at high densities and high speeds. This also entails in using less energy. Therefore, the downsizing to the nanometer level can provide us not only the miniatures, but also completely new devices. Nanotechnology, that is nanoscale science and technology, is recognized to be not simply a field of understanding of materials and phenomena or development of technology, but an intersectional, general, and fundamental concept concerned with various industrial and social fields, such as materials and manufacturing, electronics and computer technology, medicine and health, aeronautics and space exploration, environment and energy, biotechnology and agriculture, and national security. The materials and devices that nanotechnology has given the world are used in a wide range of systems and machines today. And it has an outstanding breadth of real and potential applications. Thus, the propagation effect of nanotechnology is immense. And the business opportunities it creates are both numerous and diverse. And it has a multi-billion-dollar market. It is regarded as a key driver to have influence on future industrial competitiveness of the developed countries, as it allows materials to be built up atom by atom. It is also recognized to have a strong character of new field fusion science. Its implementation content is very general and widely embraced. And the list of materials being developed commercially using nanotechnology is growing at a very fast rate. While nanotechnology may bring about major advances in medicine, manufacturing, and computing, it may also bring significant new health hazards. Apart from that, various militaries can develop new destabilizing weapon systems at a cheaper cost. Also, terrorist groups can develop dangerous tools for destruction. So there is still a lot to learn about the potential benefits and risks of the technology. And given the risks, what are the regulations involved? Are companies obligated to notify government authorities if they import, use, or manufacture nanomaterials? It is an area where researchers and policymakers should very seriously focus on and understand its implications in social, political, and economic spheres. This is a new field of study for most of us, and it is very important. And very few have been studying this new technology. So we have a lot of questions on this subject. So we are extremely glad to have Professor Uday Bhaskar Reddy to share his knowledge on this dynamic subject. We are thrilled to have you back with us, sir. Professor Uday Bhaskar Reddy, a retired professor of environmental sciences, served as head of department and chairman, BOS, and Senate member, Andhra University. He has teaching experience of 30 years and has published 100 research papers and co-authored 6 books. He has been awarded for his work by various organizations and committees. His research specialization area includes plant-animal interactions, eco-development, and global environmental problems. We are most honored to have a distinguished professor in our midst. Now, before I hand over the floor to our moderator, as per our tradition at Telangana Jana, I would like to read the preamble of our Constitution. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic, and to secure to all its citizens justice, social, economic, and political, liberty of thought, expression, belief, faith, and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact, and give to ourselves this Constitution. Now, I would like to hand over the floor to the moderator. Thank you.
Thank you, Jim. Thank you. Telangana Jana Zoom online meeting ku చేసినటువంటి డాక్టర్ రెడ్డి గారికి ఇతర సభ్యులు మిత్రులందరికీ స్వాగతం. ఇవాల్టి అంశము చాలా ప్రధానమైనటువంటి అంశంగా నేను భావిస్తూ నానో టెక్నాలజీ ఉపయోగాలు నష్టాలు అనేటువంటి అంశం మీద డాక్టర్ ఉదయ్ భాస్కర్ రెడ్డి గారు వారు కీలక ఉపన్యాసం ఇవ్వనున్నారు. వారు ఆంధ్ర యూనివర్సిటీలో ఎన్విరాన్మెంట్ సైన్స్ డిపార్ట్మెంట్లో హెడ్ డిపార్ట్మెంట్ గాను, వడస్పై చైర్పర్సన్ గాను, మరియు సెనెట్ మెంబర్ గాను, మరియు 32 సంవత్సరాల టీచింగ్ ఎక్స్పీరియన్స్ గాను, వారు 32 సంవత్సరాల కాలంగా టీచింగ్ ఎక్స్పీరియన్స్ ఉంది వారికి. వారు అట్లాగే 100 ఆర్టికల్స్, తర్వాత 6 పుస్తకాలకు ఎడిటర్ గాను పనిచేశారు. ముఖ్యంగా వారు స్పెషలైజేషన్ ఎకో డెవలప్మెంట్ అండ్ గ్లోబల్ ఎన్విరాన్మెంటల్ ప్రాబ్లమ్స్ మీద వారు స్పెషలైజ్డ్ సబ్జెక్ట్ గా వారికి స్పెషలైజేషన్ ఉంది. వారు అనేక ఇతర పదవులు కూడా చేపట్టారు. వారు ముఖ్యంగా ఈ నానో టెక్నాలజీ సంబంధించి, ఎన్విరాన్మెంట్ సైన్స్ సంబంధించినటువంటి ఇంతకుముందే చేస్తూ చాలా విషయాలు చెప్పాడు. ఇది కొత్త సబ్జెక్ట్ అయినప్పటికీ ప్రపంచం లోపల టెక్నాలజీ ఎంత పెరుగుతుందో టెక్నాలజీలో భాగంగానే ఈ నానో టెక్నాలజీ అనేటువంటిది అభివృద్ధి చెందుతుంది. ముఖ్యంగా వ్యవసాయ రంగంలో కానీ, పారిశ్రామిక రంగంలో కానీ, ఇతర రంగాలకు సంబంధించి ఈ నానో టెక్నాలజీ వల్ల జరిగేటువంటి లాభాలు ఏంటి, నష్టాలు ఏంటి, ముఖ్యంగా ఇప్పుడు జరుగుతున్నటువంటి యుద్ధాలు ఏవైతే ఉన్నాయో, 2 ప్రధానమైనటువంటి యుద్ధాలు, ఉక్రెయిన్ కానీ రష్యా మధ్యలో జరుగుతున్నటువంటి యుద్ధాల లోపల ఈ నానో టెక్నాలజీ సంబంధించినటువంటి ఏదైనా విషయాలు ఉన్నట్లయితే వాటిని కూడా మనం ఏమైనా తెలుసుకోవడానికి అవకాశాలు ఉంటాయి. కాబట్టి వాటి ఈ సబ్జెక్ట్ అనేటువంటి చాలా ఇంపార్టెంట్ సబ్జెక్ట్ గా నేను భావిస్తూ నానో టెక్నాలజీ ఉపయోగాలు నష్టాలు అనేటువంటి అంశం మీద ప్రొఫెసర్ యువి రెడ్డి గారిని మాట్లాడవలసిందిగా వారిని సాదరంగా ఆహ్వానిస్తారు.
Thank you very much, sir. Thank you for your nice introduction. I think James Garu has made my problem very easy. I think I can skip my introduction to the subject. He has beautifully covered that aspect. First of all, I would like to thank Ramarao Garu and Reddy Garu for giving me this opportunity to interact with these peers this day. Sir, first let me explain why I am taking up this problem and how I am competent to this. As a professor of environmental sciences, see, we look for the cause and then consequences, and cause and consequences is okay, but we rarely think about the remedies. So for that reason, we have to first look into the technology, science, technology. This science and technology is responsible for the betterment or worsening of the environment. So far, we have faced the bitter legacy of chemical technology. After that, we are eagerly waiting for an alternative technology. That means a green technology, clean technology. In that pursuit, so I have been looking into the other alternatives. For example, this biotechnology, then this nanotechnology, and these such technologies, I think they are going to at least address some of the major issues faced by the planet and people. So today I would like to explore how this nanotechnology is going to, yes, come to the rescue of our environment. See, this sustainability, everybody world over, everybody, they are stressing the point of sustainability, sustainable agriculture and sustainable development, sustainable economies and all these things. So for that, sustainable resources is a must. Already once I have covered the sustainable resources as subject also. So sustainable resources, it is a vital aspect. Right now, we are consuming resources in larger quantities. Our industries are utilizing them, and only that the efficiency is only to a certain extent, and most of it is being coming out as waste. But we have to minimize the resources usage, and we have to conserve them, and we have to think about the creation of the resources. In that pursuit, this nanotechnology, it will be having some edge. Just like this biotechnology also, because in the biotechnology, majority of the resources are renewable in nature. Whereas in the chemical technology, the resources are non-renewable. That is the problem. One day or other, I think we have to get with a resource depletion situation. And in the biotechnology, yes, resources have to be grown on the land, and our land is also, it's a limited resource, and the population is increasing, and land is not increasing at that proportion. So now we have to think about how to minimize the resource consumption, how to conserve them, how best we can, how to increase the efficiency of the resource utilization. So all such aspects are very much there in the nanotechnology. But at the same time, don't think that nanotechnology is going to address each and everything. See, these thrills and threats, I can say otherwise, the wonders and blunders. Naturally, the entire world community will be eager to look into wonders at the initial stage. At some point of time, we belatedly will be looking into the blunders. So let me touch most of the wonders at this. We are right now, we're in the initial stage. So in the growing stage of this nanotechnology. So let us look into the wonders first, and then some of the blunders also, I think, how this nanotechnology is going to affect the environment. See, the irony is the same science and technology, it has to play two roles, a villain role first and then hero role. So it is playing as a villainy role in spoiling the environment. So to correct that, Again, we are seeking the help of the science and technology. But here, unlike the situation on the celluloid, here the hero is weak, villain is strong. So that is the reason why our environmental situation, the fight is continuing. So anyhow, so I would like to share my PPT. Okay. Yes. Please allow me to share my PPT, sir.
Yes, you can.
First one has to be removed. Not this one.
We can't see it.
Yeah?
We can't see it.
Clear.
They can't. No, they can't see it. It's
See some thrills and threats from nanotechnology in the areas of environment and human health. Okay. I think James Garu has helped me. He has helped me in saving at least 1/10 of the time. He has given a beautiful introduction about nanotechnology. See, nanotechnology means, say, small particles at atom and molecules level. So 1 nanometer is equal to 1 billionth of a meter. Is it audible, sir?
No, it is audible, but your PPT is not visible, sir.
PPT is not visible.
PPT is visible, sir? It is visible.
Partially, is it partially visible?
Yeah, but that thrills and it's
I think I have to change. We have to remove this.
that has to stay. That has to stay.
Both of them. So,
yes, please go ahead, sir.
how to remove that, sir? That bar? Yeah, bring it to me.
Resharing. And now see what application is. Ask them if it's visible.
Yeah.
Can they see or not?
It is visible now, sir.
Can they see?
All right, sir. Sir, this is really it is a wonder, sir. This is a bouquet I am offering to all of you. This is a nano bouquet.
Thank you.
So Cambridge University professors from UK, they have developed this, sir, utilizing the nano particles. They have grown this one. Okay.
So can you make it full screen, sir?
Yes, sir. This one. See, with the silicon carbide, the nano bouquet with the silicon carbide. It is a formed from the silicon carbide nano waves grown from a wafer phase. During the growth process, the nano waves fuse together to form the intricate 3D structure visible, sir. This is the wonder made by the Cambridge University professors, sir. Yeah. See, this is the nanotube. It is a 50,000 times thinner than human hair. So nanoparticles generally they range between 1 to 100 nanometers. Sir, if you take a human hair, it will be 1 lakh nanometers diameter. At the same time, if you take a paper thickness also, it will be roughly from 40,000 to 1 lakh nanometers. And this this nanotechnology, it is hyped because nowadays we are facing resources shortage, resources depletion, some incurable diseases like cancers, and the power problems because we are heavily depending on the dirty fuels, that means fossil fuels. So we are looking for clean and alternative fuels, but where the batteries weight is a big problem for the electric vehicles. And for all those things, even for the harvesting of the solar energy also, the solar panels, its efficiency, these are all problems. So for which we are looking into the nanotechnology, sir. Nanotechnology, I think definitely it will come to our rescue. We are hoping. See, it cures diseases, it eases renewable energy problems, supercharge our computers. Our computers, say, right now, the miniaturization of computers, it has come to a halt. Because if you are going to introduce transistors, I think a lot of heat will be accumulated and you cannot double this transistors there, sir. Capacitors, transistors there. So for which invariably we have to look for the nano transistors. So clean up the environment, convert seawater into cool water. Nearly 50% of the global population, they are facing acute shortage of potable water. So here afterwards, I think we have to think about desalination and get the potable water, for which if you are going to rely on the conventional processes, you need energy. That energy right now, it is coming from the thermal powers. From thermal power means you are releasing carbon emissions. Carbon emissions, it ultimately is ending up with global warming and climate change and several environmental issues. So this nanotechnology is going to come to our rescue. We can convert seawater into potable grade water with using this carbon nanotubes. I will go in detail afterwards. Achieve sustainability. So with all these things, I think we can dream of sustainability in near future. What more thrills you want other than these? Okay, see, look into these things: copper, lead, zinc, chromium, coal, oil, bauxite, all these metals. I think they are non-renewable. I think one day or other they are going to deplete. I think copper may, if we are going to consume these metals at the present rate, within another decade, I think copper may be exhausted, lead for another 25 years, zinc 50 years, chromium 35 years, coal for another 300 years, oil 30 years, bauxite. So like that, the resources depletion is imminent. So in this state, I think we cannot dream of sustainability. So it is a high time to think about either we have to conserve the resources or we have to create additional resources. Sir, this is one of the wonders. See, they have used 15,342 atoms. Yes, these things were used to prepare a shaft. A gear. It is one of the largest nanomechanical device ever modeled in atomic detail. See, these are the low friction molecular bearings. So with this, yes, your required raw material is greatly reduced and the friction is reduced, and they are very stronger. They're very strong. Durability is more. So in that way, your maintenance is also, it is very less. Coming this nano chips are coming. Nano chips. Nano chips means, see, please look into this finger, sir. A small dot is there. That dot is a nano chip. That dot, that size is a nano chip. So in that chip, you can see, for example, silicon transistors, they generate heat and waste power. Further reduction in chip size is limited according to Moore's law. The Moore's law says for every 2 years, the number of transistors are doubling. And the doubling means we are increasing in order to get the more speed. But now the space is a limiting factor now. Now we cannot double the transistors numbers. Then what to do? We have to miniature, we have to minimize the transistor size. That is possible only with carbon nanotubes. With the carbon nanotubes, we can successfully overcome this problem. You see here at the bottom, that is the computer built with carbon nanotubes. It is a breakthrough by Stanford University people. It avoids the heat and use less power and space. Okay, this is another wonder as far as the computing is concerned. So one more wonder is there. Now quantum computing is there. Right now, if anybody put a question, which one is the fastest computer, means readily we will say supercomputer. So supercomputer, after supercomputer, quantum processing computers are coming. Quantum processing, their speed is unassuming. For example, for 20,000 years duration work, it can be finished, completed within 200 seconds if we switch over from conventional computers to this quantum computing. So that is the speed and efficiency of the quantum computing that is possible with the nanomaterials. See, this nano biotech hard drive, it is the future of that person. So nano biotech means here nanotechnology and biotechnology, both are mixed here. So this is the bacteria, Magnetospirillum magneticum. This name itself, it indicates a clue that some magnetic synthesis is taking place in this bacteria. See, this bacteria is capable of eating iron. It eats iron. Inside it synthesizes the magnets, tiny magnets. And those magnets at tiny level, at a nano level, they can be exploited as a potential hard drive for the future computers.
Sir, I think you have to
Yes, sir.
You have to click on this slide, sir. Then only it is visible for us.
Sir, I have a bar. I think that has to be removed, sir. I think if anybody know how to remove it. Okay, I will do one thing.
You have to double click on the slide, sir.
Okay, sir. Is it?
No, that first picture itself is visible. Yeah.
Is it visible now?
Yeah.
Yes.
Yeah.
Yes. Nano robot. Generally, it is used for spying purposes. See?
Yes. Yes. Yes.
Electronics are there, cameras are there, and sensors are there. All those things, I think, is very is a small one. I think we can hardly note one. See, this is another one where for space technology, space missions, the weight is a problem. Another thing is the metals which are used for these spaceships and all these things, they must be hard enough to withstand the high temperature and high pressures and other radiations and all these things, for which invariably we have to explore for the nanomaterials, because nanomaterials are known for their strength, known for their hardness. So here another milestone in emerging nanotechnology, it is achieved by NASA engineers to make spacecraft instruments compact and sensitive and very hard also. I think they have succeeded, and it's one way it encourages the space programs. Another thing is their suits also. New nanomaterials to shield space radiation. How best we can escape the space radiation? For that, they have fabricated. That means they have fabricated the suit which can withstand the radiations. Radiation protective fabric or body covering is possible now because of this great invention utilizing the nanotechnology. Another thing, nanomaterials strengthens defensive devices. Okay, our body armors, the bulletproof things or bulletproof cars, all these things we can involve nanomaterials. They give unusual strength, and we can escape from all those threats. It strengthens defense material of bullet shields and other defensive devices against biological and chemical attacks also. Yes, this is another thing. And now I would like to just confine to the industrial, how to mitigate industrial pollution, global warming, relying on nanotechnology. Right now, entire world it is afraid of carbon dioxide emissions, because already our planet has witnessed 5 mega extinctions. But before our arrival, those 5 mega extinctions, and now 6th one is going to take place, and this 6th one, it is going to be steered and guided by human Homo sapiens. and this sixth mega extinction is steered by the carbon dioxide molecule as a weapon. Okay, so how to mitigate this one? How to escape this one? This is possible with nanotechnology. Yes. How? Nanostructured membranes can separate methane or carbon dioxide from exhaust. See, while burning the fossil fuels, we are releasing carbon dioxide, methane, and other greenhouse gases. These greenhouse gases are blamed for the global warming and climate change. So, how to just capture those greenhouse gases? How to utilize them or how to bury them? Somehow we have to think about that. We should not release carbon dioxide emissions into the atmosphere. That is the only solution to the global warming problem or climate change problem. So for which now at the stacks, while releasing these emissions, yes, these people can simply they can filter and they can capture specifically carbon dioxide and other greenhouse gases. That is possible with the help of the carbon nanotubes. They can trap greenhouse gases up to 100 times faster than other methods. See, even automobiles are also, they are releasing the carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxides, several gases. They are coming out of the automobile exhaust. These can also be, yes, filtered and captured. For example, you see, diesel exhaust soot is filtered through carbon nanotubes, and the soot is used to produce carbon nanotubes through laser vaporization. So the interesting thing here is filtered waste becomes the filter. That means, you see, nanostructures or nano materials means, I think, don't think that they are the foreign substances. Yeah, I think in the day-to-day life, I think we come across with several nano particles, natural particles, and some biological particles, and some are synthetic particles. See, as far as the nano particles, natural things are from sea spray, from ocean spray also, we are seeing some nanoparticles, some volcanic ash, or some these combustion particles, forest fires and all these things. These soot is a best source for these nanoparticles. Actually, for the source of this one, even we have to go up to the Big Bang theory. Even the Big Bang theory also, at that time also the nanoparticles are seen. Even during the volcanic eruptions. See, all these things they contain. So these combustion products also, they contain a lot of nanoparticles. That soot, that carbon black, that one, that carbon soot. I think you might be knowing that the kazal that is prepared in our rural side by just burning a lamp, oil lamp, and collecting that soot. That soot will be mixed with an oil and they use it as a kazal. Katuka. So what is that? There is nothing but this is one way of preparing the nanotubes. This is also very, very soft, very soft, because it is largely it is produced, because that is why it is visible to our naked eye. And another thing, this automobile soot, that means the soot coming from the automobile exhaust, this is also, it is a source of nanoparticles, and that can be again converted into nano filter. So that is the one. This is the wonder here. The interesting thing is filtered waste coming out of the automobile exhaust emissions. It will be again turned into filter. This is an artist's viewpoint of methane molecules flowing through a nanotube. This is a nanotube, a tube-like structure with a 2 nanometers diameter. This tube diameter is only 2 nanometers. Within that diameter, you see how these methane molecules are flowing without any resistance. The breakdown of volatile organic compounds in air. To break down volatile organic compounds in air, gold nanoparticles embedded in a porous manganese oxide as a room temperature catalyst can break down volatile organic compounds in air. So this is another is environmental friendly green process. To remove nitrogen oxide from smokestacks. Nitrogen oxide also, it is one of the stackhouse emissions. So this is also, it can be removed using a nano catalyst containing cobalt and platinum. Nitrogen oxide from smokestacks can be removed. Say these are the instruments through which we can remove from the polluted air carbon monoxide, nitrogen oxides, formaldehyde, molds, spores, odors, and several other lot of pollutants can be removed from this utilizing the nanotechnology based filters. See, nanotechnology filters are available in the market. You can get them from the Amazon or something like that. These filters, simply you stick those filters to your air conditioners. You stick those filters to your existing air conditioners. You can prevent the dust particles, and lot of air pollution indoor air pollution can be reduced. I think it costs very, very low also. Another wonder of the 21st century is nanoparticles, nanomaterials. Don't think that they are very wonder chemical. That means they are very costly materials. You see, if you look into this lead pencil, actually this is not lead, but we treat it as a lead pencil. But in fact, it is a graphite. It's a graphite pencil. With that graphite, we produce graphene. The graphene invention was made very recently. That means in the 2010, for which a Nobel Prize was also given. And this graphene is going to revolutionize the 21st century. Graphene revolutionized 21st century. Graphene is one atom thick, single layered, wonderful material. Single layered is a wonder material. It conducts electricity 10 times faster than copper. It is stronger than steel. It is highly responsive, lighter, transparent, thinner, flexible, foldable, wearable, and printable on different substrates. So that means here afterwards, I think your solar panels will be available in different shapes. I think you can order your car cover with the facility of harvesting solar energy. That means a foldable solar panel will be printed on your car cover. So that way, foldable and different substrates. Coal yields graphene at a cheaper rate. So that means this graphene is a wonderful one. It's very cheap. Nano solution to global water crisis. Already I have explained this one, how it is going to. One atom thick graphene, pure carbon, membranes of 1 nanometer pore size to remove pollutants and salt from seawater. Yes. Other than water molecule, H2O, all rest of the other molecules, they are greater than the pore size. Greater than the, yes, carbon nanotube diameter. Carbon nanotube diameter is only 2 nanometers. And your water molecule diameter is less than 2. And your pollutants, including your bacteria, virus, and all your salt, guilt, everything is more than 2. So that is the reason why if we are going to pass the seawater through these nanotubes, only it allows only water, only H2O molecules. So pure water will come. Okay, in that way, your polluted water can be, yes, converted into very quality water, and your salt can be removed, and you can directly, you can have access with the seawater, and desalination will become very environment friendly, very cost effective. Inexpensive desalination using carbon nanotubes, taking the salt from the sea. It is 2010 R&D. You see, it is one among the 100 awards in 2010. Water pollution, industrial water pollution. You see, this is the thing here. This one, first one, this is a microfilter. This is ultrafilter. This is nanofilter. This is a microfilter. It can filter only macromolecules, macro size. It allows bacteria, viruses, and all these things. They pass through these pores. Pores are with greater diameters. So microfilters, they won't give any safety to you. Coming to the ultrafilters, to some extent, ultrafilters will give you the larger particles will be stopped here, prevented here. But coming to nanofilters, almost all these pollutants, your bacteria, your viruses, other particles, other elements, everything will be prevented by your nanofilter. So nanofiltration is the best one for treating the water, and you can get quality water very cheaply and very effectively. treating polluted water using consumables. See, for example, this is a carbon nanotube with 2 nanometers. This is also carbon nanotube, second one. This is third one. So here polluted water is there above, polluted water with a different species of pollutants, including H2O. So you see, water is coming only these tubes allowing only water, and water is collected here. So this is the way how this polluted water is treated. Nanotech water purifying tea bag. It is there available in the market. Yes, utilizing this, it is very cheap also. Air, carbon, yes, ultra thin nano scale fibers are there within that. So this is an activated carbon in a tea bag. By dipping this bag, your water can be sterilized. That means bacteria and viruses can be killed instantaneously, and you can very confidently you can drink that water. It is cost also is very less. So in the South Africa, I think they have come out with this nanotech product. This is a wonder. Another one, our Tata people. Tata people, they have released nano car into the market. Nano car means it's a dwarf car, small car, not nano. See, here they are really exploiting the nanotechnology. They have released a water filter where electricity is not required. Electricity is not required. That material, nano material, it is capable of filtering the water. It can make the water as germ-free. No bacteria, no virus, nothing doing. Nanotech fabrics advantages. See, here the textile industry, it is going to exploit the nanotechnology. Now, wrinkle-free, waterproof, and stain-proof. Such fabrics are available on the market. No need of ironing, no need of washing. When there is no water, when there is no wrinkles, when it won't catch any dust. So there is no need of washing at all. I think you can throw all your washing machines and your iron boxes and all these things. So you can save your resources, water and electricity. Lot of advantage here. See, nanotech fabrics, no wash, no ironing, wrinkle-proof, wrinkle-free, dust-proof, and water-free cloths. Stain-resistant nanotech fabrics from Emeryville company. Yes, they are available. Nano-treated fabrics. They repel spills and stains, stay clean, looks new, and last longer. I think you need not wash these fabrics. I think nothing will be there on that fabric. I think it won't stick to that one. Stain resistant fabric. UV protection and anti-glare scratch resistant lens are coming. I think, see, you need not change the glasses unless your power changes, because say no scratches, no breakages, nothing doing. Such type of strength it is given by the nano coating solutions to these glasses. See, Ultima Protect from Asian Paints. This is a commercial product. Which one? It is assures you. I think these paints can give you a good amount of protection from the environment. So here some nanotechnology it is used here. That is why they can withstand the dampness, and they can minimize the damage from the algae. The cracks are also minimized. The color fading also minimized. Sometimes the cracks also will be sealed. So these are the advantages of this nanotechnology here. Another advantage is, see, color changing paints are also coming. See, our people, they are very fond to change colors. They never satisfy with a single color or a routine color. They very frequently they change. See, some people they go for totally, even the footwear, the everything, ornaments, dress and everything they change. So in that way, in your room also, I think you need not compromise. You need not settle with one color, either pink or green or something like that. You can change your colors. I think across this rainbow, all the colors you can enjoy. So how it is possible? Because of the nano coatings, nano circuits, programmable matter. So simply you can program them using your smartphone. You can change color like chameleon with a click. Your car also take. Just you go for this nanotechnology, nano paint. Use that nano paint and it gives you different colors. Chameleon, like you can change your car color. Like how chameleon changes its colors? There also nanotechnology is involved. There also nanotechnology is there. Chameleon skin. It contains nanotechnological particles, nanoparticles. Those nanoparticles, if this chameleon, if it is very relaxed mode, it gives a green color. It's a blue color. If it is in a agitated mode, immediately it changes to yellow color. So this change of colors, that is because of this nanoparticles. So the same biological process is being exploited here to make your car to change colors. The super absorbent, a complete solution to clearing up of oil spills. See, nowadays I think we come across with the oil spills, wreckage of the oil containers and all these things. So where I think these solutions, nano solutions, they are coming out very, very efficiently, and they can transform this oil slick into a soft, easily removable gel. Nanotech exhibit eco-friendly nano home cleaning solutions. Yes, the home, you can go for these nanotechnology based solutions. Not only these things, if you go to any petrol bunk, there you can find at least minimum half a dozen varieties of items based on nanotechnology. See, scratch-proof paints are there, cleaners are there, scratch-proof paints. All these things are nano products. See, what are the additives? In your diesel or in this, some additives are used. Those additives are also nanotechnology based oils. Okay. Nanotech in energy production. This is another area where we are, I think, we are eagerly waiting for the wonders. Because you see, energy means we are immediately going to switch over from this fossil fuel energy to some clean and green energy. That clean and green energy, right now we are seeing only in the solar and wind energy. Solar and wind energy, right. Harvest of solar energy, it is one problem. Day and night, only I think daytime only we will be having solar light. And even I think if you can increase the efficiency of catching, I think the nighttime also, the twilight also can be exploited for energy capture. So all these things are possible because of the nanotechnology, So right now, the 30% of the efficiency to the tune of 30% efficiency, it is possible with the help of nanotechnology in energy harvesting, solar technology. So then next thing is preservation. How to preserve that energy, how to conserve that energy, how to store it. You need battery. In that battery, how to store that energy. So storing is also another big headache. Right now, the big problem with electronic vehicles, everybody, electric vehicles, everybody, they're very happy. Electric vehicles are going to, fill the, all roads. Okay, it's okay. If electric vehicles are going to run on our roads, I think almost all your urban pollution, I think it is going to be solved. But what are the impediments? Because you see, in the electric car, the accommodating batteries are very heavy. I think nearly 1,000 kgs of batteries. I think 50% of your car weight is occupied by the batteries and volume. And that weight also your car has to carry. And again, the speed also, the speed, mileage, inner space, and consistency. All these are problems. So cost also, lithium ion batteries. Right now, all electric vehicles, they are relying on lithium ion batteries. Lithium is a very costly one. And lithium, at the present rate, I think people are they're estimating. It is another, I think by 2040, all lithium resources on this planet are going to be exhausted. At this rate of, exploiting this lithium for making the manufacturing of batteries, lithium ion batteries. So it is the high time to think about the alternative batteries. In place of lithium, we have to search for. Already, I think things are fast moving. and people are just making this graphene battery. Graphene means, yes, it is coming from coal, graphite. From graphite, graphene is coming. So graphene batteries are also going to flood the market. And another one is sodium ion batteries are coming. Sodium ion means, yes, plenty of sodium is there. I think we need not be panic about this depletion of the resource. So in that way, this technology, it is going to revolutionize. 3D honeycomb graphene, solar cells become cheaper. 3D honeycomb graphene means, that means what is the specialty, wonder of the nanoparticle? Your total surface volume will be unassumingly it will be increased. That is the wonderful property of the nanomaterial. So that is the reason why, if it is a three-dimensional honeycomb-like structure, see there this graphene. So your hydrogen ions will be stored very efficiently. More number of hydrogen ions will be stored there, or more ions, energy will be stored there. So that is the advantage of these things. Nanotech to overcome hydrogen storage problem in fuel cell powered cars. See, graphene layers increase hydrogen binding surface in the fuel tank, which results in a higher amount of hydrogen storage and a lighter weight fuel tank. As a result, more fuel is loaded within that limited volume. You can reduce the battery compartment. You can reduce the weight of that. And another thing is, because nanomaterials are involved here and narrow structures are involved here, your accidental risk also it is minimized. Safety aspect also it is increased. Producing a gasoline from carbon dioxide CO2 conversion. See, this is a solution to your greenhouse problem. That means your global warming and climate change problem. At the same time, for your energy crisis also. Carbon dioxide, it is coming by burning your fuel only. When you burn your fuel, your dirty fuel, hydrocarbon, we are getting carbon dioxide. So if you can reverse that carbon dioxide, again you will get it from fuel from the carbon dioxide. If that is going to happen, two problems are addressed here. One is your global warming problem. No need of the industrial people to release carbon dioxide to the atmosphere. When carbon dioxide it is becoming or converting into fuel, a marketable thing, I think they won't let out carbon dioxide. Instead, they capture the carbon dioxide and they store it and they convert it into commercial product. So here, how it is going to happen? With the help of the nanoparticles. What type of particles? You see, atomically thin, two-dimensional graphene nanosheets. Graphene nanosheets, two-dimensional, atomically thin. They are designed with semiconductor-like nitrogen as a catalyst system. So here, they are acting like semiconductors and like nitrogen as a catalyst here. A major achievement of the recent period. This is a major achievement. Converting carbon dioxide into gasoline. See, I will show you another picture here. Here you see, this one, CO2 and H2O, carbon dioxide and H2O generally, even any combustion process you take, any combustion process, including our respiration, animal respiration also, what are the outcomes? The waste coming out of the respiration is only H2O and CO2, water vapor and carbon dioxide. When these things are allowed, permitted through this catalytic compartment, yes, ultimately under solar light, and that means the sunlight, this energy is utilized in presence of the copper catalyst nanoparticles here. So ultimately you will get CH4 methane, H2 hydrogen and oxygen. All are commercially valuable products. See, your carbon dioxide is a threatening particle. It has no commercial value right now. But if it is converted, taking the help of the nanotechnology, the waste can be converted into wealth. See, CH4 is a methane, it is a combustible material. We can exploit it as a fuel. And hydrogen is also a fuel. And oxygen, right now, I think I need not highlight the importance of the oxygen. I think all this COVID pandemic has given us enough experience of the advantage, this necessity of the oxygen. Converting CO2 into usable energy with nickel atoms on graphene sheets. Yes, several people, several scientists, they are doing experiments day and night, day and night. Very soon, people will come out with a sensational finding. You see, that 20 years back, in an international conference, that conference was conducted on these energy resources. Everybody, they expressed their opinion. Sir, within another few decades, the oil resources on this planet are going to exhaust completely, totally. And in that case, what to do? We cannot run our vehicles, automobiles without fuel, without diesel, without petrol, without CNG. They cannot run. When the people and the hydrocarbons are drained out, we have to revert back to our ancient primitive life technology. Horse rides, bullock carts, and donkey loads, such type of things I think we have to. But one among them, having some positive bent of mind, some positive attitude, he stood and he gave an assurance. See, dear friends, don't be panic. 3 decades time is not a, it is a longer period too long a period to our scientific community. Within 3 decades, our scientific community will definitely come out with a sensational finding, with an alternative energies, with cheaply available and clean and green fuels, and divide of all these environmental evils. In that case, in that situation, there will be enough oil in the petrol bunks, but there won't be any takers. You take my point. So in that way, yes, ultimately he convinced the entire body that is going to be a reality because of these things. Very soon. Already the petrol bunk people, I think they are in preparation to maintain charging stations, electrical charging points to the vehicles. They are in the transition stage. You see here how this carbon dioxide is going to convert it here. Nickel nanoparticles, they are doing wonders here. How they are doing? Nickel as a metal. See, another peculiarity, specialty of nanoparticles is, you see, you decrease the size, smaller the size, its properties are going to change drastically. So that means when the properties are changing, for example, you take gold, this gold material, this is yellow, very bright, very solid, it is non-reactive. That is those are the properties of the ordinary gold. But if you go to the nano gold, the properties are totally different. It is seen in liquid form. It is either red or black in color. It is red or black in color, and it is highly reactive. So you see, different properties. So in that way, when a different set of properties are seen at nano level, so each metal, each element is going to play double role. That means your periodic table number is going to be enhanced. That means your resources coverage, it is going to enhance. That is the advantage. So here you see carbon dioxide, nickel as a metal. I think that is another route where only hydrogen, little amount of hydrogen will be evolving. But if we are going to replace this metal, nickel metal, with nickel nano material, nanoparticles, atom level, these particles are going to convert CO2 into CO. Why CO? You see, when you burn hydrocarbon, when you burn your fossil fuel, your petrol, your diesel or CNG, those hydrocarbons, it is going to be converted into carbon monoxide and carbon dioxide. Simply you are reversing that process. While combustion, it releases energy. But here, the same energy which lasts, that energy, it is supplied by the solar light, sunlight. Taking that energy, this carbon dioxide, it is going to be converted into carbon monoxide in presence of the nickel nanoparticles. So this is going to convert it into methane. So this is a very, very usable energy. 97% of efficiency. It is on the graphene sheet. It is going to happen on the graphene sheet. Graphene sheet itself is a nanomaterial, nano product, and the nickel atom catalyst also, it is a nanoparticle. That is the wonder of this means. That means the problem to a sixth threatening problem. That means global warming and climate change problem issue. That cause carbon dioxide, it is going to be addressed here and it will be converted into usable energy. So our energy crisis is solved and that global warming problem is also solved. Thin film solar cells, already I have covered this aspect. So nanotech panels capture 30% of solar energy, including individual infrared rays. That is the advantage here. Only 0.1% space of the earth is enough to supply clean energy to the entire world. But only thing is, we must gear up to capture that energy by exploiting these nanomaterials. Your clothes, car roof, your doors can supply energy. The need for oil can be totally eliminated. See, your walls can be painted with nano paints. Those nano paints, they can absorb the light and they can supply energy to your house. You see, flexible tube shaped photovoltaic cells could result in solar powered clothing. Yes, the cloth, the fabric also, it is nano rods are mixed with the fabric. So these things are going to capture the energy from the sun and this will be, supplied to the transmission lines. You see, gold nanoparticles using sunlight can generate hydrogen from water. See, where from hydrogen? Hydrogen is there, very much there. Hydrogen and oxygen, it combines and forms of water, H2O. But how to release hydrogen? Releasing of hydrogen from water is very, very energy intensive. So we have to rely on the thermal power. That means coal burning. Coal burning means that is linked to the threatening problem, global warming and climate change. So instead of that, you go for this one, nanotechnology. Exploiting the nanotechnology, utilizing gold nanoparticles. I think you can split this one water into hydrogen. So you can, instead of filling your tank with the fuels, you can fill the water and you can release the hydrogen. Self-heating roads save cars from icy conditions. See, in Europe, especially in Europe, very recently, Americans also, I think, they are facing this problem. See, because of the minus degrees. Because of minus degrees, a lot of snow will be falling and accumulating on the roads. I think the roads will be blocked totally. I think it is highly impossible to drive on those roads. They have to remove all those things by spending energy, electricity. So again, that is linked to your carbon emissions. Instead of that, what these people are doing, the self-heating roads are embedded with the sheets of carbon nanofiber, nano paints. They are warmed and see with the natural heat or natural light. From that light, they absorb heat. Self-heating mechanism is there. Self-heating mechanism. I think that temperature, they can heat up from minus 10 degrees to 0 degrees centigrade very easily. So when they self-heat the roads, automatically the deposited ice will be melted and the line will be clear for the transport. So this is another advantage of the nanotechnology. So another area where this energy, see, nanotechnology makes poof power, and that means, see, for example, our sewage treatment plants are there, where this toilet, our septic tank waste are also, I think, linked to these things, and where they are relying on this nanotechnology now. With nanotechnology, they are in a position to generate energy using these nanoparticles. Nanoparticles they are using here. Another area where self-cleaning glass. self-cleaning glass. That means the auto-cleaning windows. Auto-cleaning windows. Your windows can be automatically they clean. I think you need not bother about the cleaning of these things. You need not invest any amount in the name of maintenance. How it is possible? Nano-coated glasses will be acting photocatalytic and hydrophilic. Photocatalytic means when those glasses are given with the nano things, that these nanoparticles they act as a photocatalytic. Because of this photocatalytic activity, the organic debris deposited on the glass, it will be splitted. It breaks. It breaks. Afterwards, wherever water molecules are there, wherever humidity is there, or rain is there, or dew is there, those things will be captured and it will be evenly spread on the glass. That means that water is going to wipe out these the organic debris. So in that way, these are the self-cleaning glasses. I think you need not invest a single pie in the name of maintaining those glasses. Nanotech applications in automobiles. You see how many applications are there? You will be wondering. You see, hardness, friction breaking resistant, already people are using. Even the tires are also in the tire manufacturing also, they are using carbon nanotubes. With that, enough hardness will be there and durability is more and security, safety is also it's more. And nano varnish, scratch proof, scratch resistant. This proof already it is there in the market. And carbon black in tires, fuel cells, solar cells are there, sodium ion, cheap batteries are coming, usage of infrared reflectors, anti-glare coatings are there, corrosion protection is there, high strength steel, dirt protection, repellents are there, fragrance in the cabin, catalysts and fuel additives are already there, self-cleaning glasses, self-heating paints, extremely hard aluminum oxide nanoparticles are used to give high abrasive resistance with solid impact strength. So all these benefits are, I think, already are taken, all they're exploited by the automobile industry. Coming to the medicine, nano medicine. Say we have looked into the environment, we have looked into the energy sector. These are all important areas where we are badly looking into green technology or clean technology. So here medicine is also. Right now, we are facing problem with not only with cancers, even with malaria also, even with diabetes also. There is no solution. So then how to? So again, your nanotechnology, it is going to come to your rescue. How it is going to see? A little chip that can diagnose your health. Nano chip program the skin cells to heal injuries. See, with that nano atoms, these nanoparticles, they act as a sensors. They indicate, they trigger, they activate with a particular gas or a particular product or element. That gives a gas. There is a certain thing is there. Yes, it is an indication of corona infection, or it is an indication of malaria. It is an indication of something. So in that way, this diagnostics, that means disease diagnostics are, I think now it is a revolution. It is a total revolution. Diagnostics and you see where nanotechnology and medicine meet. University of Alberta oncology professor Linda Pulaski, along with her research team, has created a microfluidic chip that can test for up to 80 different genetic markers of cancer. See, cancer is not a single species. Several kinds of cancers are there. So how to discriminate, distinguish, how to differentiate them? Highly impossible. Even now also, I think several speculations are there. If you go to one doctor, he will say something, and if you go to another doctor, he will say something. So for which a specific, authentic test should be there. So these nanotechnology based nano chips, these are all, I think, they are there to come to our rescue. Nano antimalarial drug invented by scientists of see, this is a finding from a University of Hyderabad. See, the February 2018. What is that? You see, the malarial fever. See, we have been doing war against malaria, against mosquito. Mosquito is a vector for this spreading of this malaria. So, in spite of waging war against the mosquito, or world over, I think still mosquito is, I think it is the winner. It is the winner. I think we are unable to control this one because malarial fever has a periodicity. Whenever a temperature is there in your body, see, when malarial parasite more active in your body, then as a defensive step, your body or your brain gives a command. You increase body temperature, create unfavorable condition to the malarial parasite, so that you can suppress the spread of the or multiplication of the malarial parasite. So, as a defensive strategy, our body temperature will be increased. So, your increase, the rise of your body temperature is an indication that your malarial parasite is active in your body. At that time, if you administer your drug, that drug, it will definitely, it will target the parasite and parasite can be controlled. What we are doing, we are swallowing the tablets, morning one dose or evening one dose, without synchronizing this administration, that means drug administration, to the pathogen periodicity. So that is the problem there. So here, time, temperature module, time and temperature, these were synchronized here, where perfect dosage and time precision play vital role. Nano drug is released, drug also released when exactly it is required. 24/7, I think you need that dump your body with that drug, that chloroquine that is going to poison your body, that is going to, it is intentionally we are doing. How to see this nano drug is released when the temperature starts rising. Whenever there is a temperature rise, your drug starts releasing inside the body and stops when the temperature comes down. When temperature comes down means your parasite already it is subsided. It is not in phase. Then the drug release will be stopped and efficiently the drug will be released. So in that way, very efficiently, timely, will very good. Efficiently, it can address malarial problem. So another one is still, it is everybody. I think you can verify how closer this nanotechnology is. Say home pregnancy test, a magic of nanotechnology. Home pregnancy test. You did not go to any laboratory. You did not invest huge amounts. Home pregnancy test uses gold nanoparticles, the indicator that turns color to pink. The indicator simply, if you just give, say, few drops, 3 drops of urine, you just collect. You put it on that sensor. That sensor, if it turns to pink, it is the confirmation of pregnancy. Simple thing. That is the advantage. This is nanotechnology wonder. Nanotech bandages. See, silver ions. Silver ions are known for antibacterial activity. They kill the bacteria. They kill. It acts as an antibiotic. So silver. In the bandages also, they are just simply adding nano silver, and this nano silver will take care of. I think just you put the bandage on your wound, you need not administer any antibiotic to heal that one. This bandage itself, it will take care of that. Drug delivery nano patch. For example, if insulin is to be administered, I think you need not. This patch is going to administer insulin time to time, as and when it is required. Monitoring and the exact doses will be. So in that way, almost all drugs. Artery clearing. See, it is an artist's view. How arteries are. These blocked arteries can be cleaned by nanorobots. Nanorobots, simply these nanorobots will be injected into your blood. These nanorobots, they propel, they go inside, and simply they clear the entire blocking material, the cholesterol, all this debris. It will be, yes, sir, it will be tunneled and it will be rebound. See how these nano robots are working here. Nano robots cleaning the pulmonary vesicles, collecting all these things. They act like a scavengers, robo scavengers. Nano robots and bacteria, concept nanotechnology in medicine. How? See, the medicine will be carried specifically to the target-oriented drug delivery. How it is? It will identify the culprit and it will take the drug and at the point only, at the delivery point only, it will release. That is the advantage. You need not to kill the cancer cell. See, antibiotic. If you want to kill or destroy a pathogen or a germ or a cancer cell means it should be an antibiotic. Antibiotic means definitely it will be spoiling your health. So what to do? You have to specifically administer the drug at that point only. That is possible now with these robots. You need not poison your entire body. Nano robot performing cell surgeries. They go specifically to the tumor and they can do surgery. Nano robots. Mobile cell repair nano robots. Mobile cell repairs. What is cancer? Wherever the cell is uncontrolled, when it loses its control, then it is a normal cell. So it's an abnormal cell. Uncontrollably it grows. Uncontrollably it consumes energy. Your food, everything. So that is now I think that can be controlled here. You see, I will show you. Curing the cancer. How it is going to cure cancer, you see? In a tumor, cancer tumor, it just means a layout. That means with a innumerable number of blood vessels because it requires more nourishment to tumor. And that nourishment means those nutrients comes through the blood vessels. So more blood vessels will be laid in the tumor place. So then what to do? These nano robots, they go and block the blood vessels. They plug the blood vessels so that the food will be made unavailable to the tumor cell. And another thing is, you see, cancer, the killer cancer cells by rupturing their cell walls. These robots, what they do, they rupture the cell wall of the cancer cell. That is this is another aspect. This is through destruction. It is by making the resources unavailable to the cancer cell. In that way, these things are going to address your cancer. See here, you see, gold nanoparticles carry cancer drugs straight to the cancer spot. You see, here is this is the cancer spot. It is abnormal growth is here, and this nano robot, it is carrying medicine specifically, and it is delivering that to this cell. And this cell is going to die. It will be killed. It will be targeted, and it will be diagnosed, targeted, and it will be killed. That is the advantage. You need not for that. You need not poison entire body. Nanotech in cancer treatment, making cancer cell to commit suicide. This is another wonder. Simply, it will change the genome. That means it gives the commands to the cell. It captures. It gives a command. It commits suicide. DNA robots carry message, activate the cell's so-called suicide gene. I think my friend Padaya is here. He is a human genetics professor. He knows better than me about these things. DNA robots carry messages, activate the cell's so-called suicide gene, which will cause the cell to kill itself. That is called as apoptosis. This process is called apoptosis. And that means prompting to get suicide, get itself undergo suicide. See, artificial muscles to propel nano robots. See how to make the nano robots to propel inside the body. Some energy is required. Where to get? So they have created some muscles like this. These muscles, with those muscles, it can propel and it can gain some energy. So this is also made possible. So step by step, these people are, yes, they are coming out with sustainable solutions. You see, skin-like sensors developed by Stanford engineers using nanotechnology, a touch, feeling touch. You see, these are new therapeutic materials based on nanofibers made of polycaprolactone. So that means if any burn injuries are there, your skin can be transplanted with these patches. See, Sophia skin is a nanotech marvel. Yes, this entire skin, it was made from this nano material, nano skin. Nanotechnology solution for radioactive waste cleanup. Titanium nanotubes and nanofibers, they are superior materials for removal of radioactive cesium iodine ions in water. So your water will be having cesium and iodine. These are the radioactive materials, and these things are also can be eliminated by way of using this nanotechnology filters. Nanotechnology can make humans immortal by 2040. Futurist says we see collaboration between man and machine by 2040. See, organ culture, your entire organs, all organs can be cultured, and your aging process. That means your genes means the software packages. Software, that software can be rewritten, that can be changed, and if you are going to change that, no question of no death, nothing doing, no telomere. I think don't move telomere. You stay there as it is. No aging, nothing doing, no death. Okay, list of 12 risks that threaten human civilization, that was given in 2015. In the year 2015, they have listed out 12 risks. What are they? For everything, good and bad is there. I think we cannot assure 100% safety in any technology. You see, this nanotechnology is also right now, I think we are very much excited to see the wonders first, and very lately I think we will be talking about the blunders also. See, extreme climate change, that is one of the risks. Nuclear war, global pandemic, already we are in the pandemic, and already I think nuclear war, I think these are all, they have rightly listed out here. Ecological catastrophe, global system collapse, major asteroid impacts, super volcanoes, synthetic biology, and nanotechnology. Nanotechnology was also mentioned as one of the 12 risks, unknown consequences, future bad governances. So nanotechnology is also not free from the threats. So that is why I would like to just finish off this one, covering the threats. I think the threats are, I think, only small things. I think somebody has become impatient. So this is the nano size and nanometer. Coarse particles, their size is, you see 10 to 2.5 micrometers. They are micrometers. If we convert the micrometers into nanometers, 10,000 to 2,500 nanometers, that means coarse particles. Your suspended particulate matters, okay, magnet size. See, fine particles 2.5 to 0.1 micrometers. That means 2,500 to 100 nanometers. So that is right now, these present technologies, it is making us to bother about this much size of the particles. But whereas if nanotechnology is going to replace those things, we have to start worrying about these particles. We have to, yes, below this line, 100 to 1, between 100 to 1 nanometers. See, this is the scale, nanoscale. Carbon nanotubes are the only 2 nanometers, and water molecule, water is 0.1 nanometer, and see, these are the antibodies. And coming to this one, virus, this is 100 nanometers, and bacteria 1000. So like that, all these things, your germs, pathogens, and all threats, all pollutants are beyond this one. That means whenever you use this nano filter, only except water, nothing will be allowed. So in that way, nano filters are very, very safe, very definite. Pathways of nanoparticles entry into human bodies. See, pathways means dermal is one route, because we use lot of cosmetics, and inhalation, it is another route, 25% chances are there, and ingestion by eating, 17%. These are the routes of entry. These entry of scientists inside the human body, indirect uptake by skin pores. Your skin pore is 5 to 20 nanometers. Okay. And your hair follicles diameter is 20 to 30 nanometers. So 5 to 20 nanometers skin pore and hair follicles 20 to 30 nanometers. Your skin, it is designed by the Almighty to give protection against the macromolecules, against bacteria and viruses. But whereas now you have created nanomaterials and now you are facing a miniature threat, that means a nanoparticles threat, which has not included in that security strategy. So your nanoparticles are very, very, very less than this one. Until that means one nanometer or 100 below that one. So these nanoparticles, they can enter into your body through your skin pores, through your hair follicles. That is there. So dermal route. So inhalation or respiratory system where CNT center, alveoli and deposit on the epithelium or air blood tissues barrier, they can go up to, yes, your brain, heart and all these things, organs. So another thing, CNT routes of entry. See, WHO statistics on asthma and allergies. Right now, 60% they say the probability of the diseases is 5%. Yes, these are the Parkinson's disease, Alzheimer's 5 million, strokes 6 million, 12 million cancer, and coronary heart is 13, and diabetes 26 million, 60 million people. They are the major percentage of the people. They are the victims of the, yes, asthma and allergies. So your nanoparticles, they are going to pose this asthma and allergy. Right now, we are facing 60 million people. So this is going to be, yes, aggravated. The threat is there. Allergies. Direct uptake of nanoparticles to nose, you see. That is the nose, human nose. This is the nose, nostrils. Before nose, I think these are all invisible. These are all invisible nanoparticles. We don't know what they are. Unknowingly and unwittingly, we will be inhaling. And these will be entering your body, and what havoc they are going to create, we don't know. See, cerium oxide, a nanoscale diesel fuel additive. By adding this additive, earlier we have lead additive. By adding lead into the diesel, it used to act as a anti-knock agent. That lead used to be a carcinogenic one. And I think we have taken a lot of measures to avoid lead to automobiles. Right now, in the name of nanotechnology, we are using cerium oxide as an additive. This cerium oxide, ultimately, it comes out through exhaust emissions. And that problem is also there. I think we have to think about that problem. Among the threats, skin pores, you see, in the electron microscopes. After inventing the electron microscopes, scanning electron microscopes, and this scanning tunneling microscope, in 1980s or so, something like that. After that only, I think it has given a boom to the nanotechnology. And we could able to see the nanoparticles at atom and molecule level. Cancer risk and damage to DNA to the users of nanocosmetics and sunscreens. You see, the threats from nanotechnology, these creams. Nanotech for UV protection. See, I think the cricketers, we used to see the cricketers, I think with white paints on their faces. What is that? That is a sunscreen. Protection against the sunlight. Because the white people are very, very vulnerable to the ultraviolets coming from the sunlight. That is why they apply white paint to their face. But the thing is, you see, by applying this white paint, that looks very ugly, and cosmetic point of view, it is not that attractive. So there is a solution for this. You can switch over to the nano paint. That nano paint is a transparent one. It is a transparent one. No color is there. So your glamour will be retained, and you will be, your UV protection will be intact. So this is the nano solution. So carbon nanotubes, the new asbestos. This could be another asbestos like them. Who knows? Today's science may become tomorrow's nonsense. And today's nonsense may become tomorrow's new science. So in that way, today we are claiming them as a wonder chemicals and this one, miracle substances. But tomorrow, experiments on pears suggest potential health risks to humans and environment. See, nowadays people what they are doing to give extension to the shelf life, they are dipping all fruits, vegetables into the solutions, nano solutions, and they are just there dumping into their marketing. So what is happening here? These nanoparticles, silver ions, they are seen even in the pulp also. After cutting them and analyzing the pulp, these silver ions were seen entering into these things. Samsung's Nanotech washer must follow bunks. See, this is a silver ion washing machine. 100 quadrillion silver ions will be pumped for each wash, because silver ions are there inside, those ions will be released. So for every wash, 100 trillion silver ions are there. After washing, you simply let out that water into the drains, and this water is going to contaminate your water bodies. So these silver ions are going to, nanomaterials are going to contaminate your water, your body. This is associated with the nanoparticles exposure. So almost all, you see, from brain to no organ is free from the threat. Toxicity of nanoparticles is largely unknown because it is a promising, it is a nascent one. Size is very small, surface volume is very large, and strength is very high. Toxicity, we don't know. We cannot definitely, there is no definite answer for this. So we have to wait and see. Nanotechnology, it should be, it needs labeling already. Our ignorance is more than our knowledge about nanotechnology. So thanks to the relevant scientists for their contributions to this subject, and to the audience also for their patient hearing. Thank you very much. Thank you very much. I think I am not expecting any thanks from your side, sir, because I would be able to share my thoughts with you. And if any suggestions are there, I think they are most welcome. And my colleagues are also there. I think Subramaniam from economics, Professor Padaya is from human genetics, and all these people, I have introduced them to Manoj Kumar Reddy Garu. I think they have also delivered lectures, and I would like to compliment this body, because I think they would be able to sustain this series of lectures. I think 400 and not 400 and odd weeks continuously arranging resource persons, and this means it is a very, very Herculean task, and we have to compliment the executive committee. Thank you, sir. Thank you.
థ్యాంక్ యూ సార్, థ్యాంక్ యూ ప్రొఫెసర్ ఉదయ భాస్కర్ రెడ్డి గారు. వారు ఇవాళ సుదీర్ఘమైనటువంటి వారి యొక్క విషయం లోపల నానో టెక్నాలజీ ఉపయోగాలు నష్టాలనేటువంటి అంశం మీద సుమారుగా 1:20 సమయం పాటు వారు సుదీర్ఘంగా టెక్నాలజీకి సంబంధించి, నానో టెక్నాలజీకి సంబంధించినటువంటి అనేక విషయాలు మనము కళ్ళ ముందు పెట్టారు. ప్రధానంగా వాటికి సంబంధించినటువంటి ఉపయోగాల గురించి చాలా విషయాలు, అంటే మనం ఇవాళ సస్టైనబుల్ డెవలప్మెంట్ గురించి బాగా చెప్పుకుంటాం. ప్రకృతి వనరులను పెద్ద ఎత్తున ఉపయోగిస్తున్నాం. ఆ వనరులను సక్రమంగా సమర్థవంతంగా వినియోగించుకోవడానికి ఈ నానో టెక్నాలజీ అనేటువంటి ప్రకృతి మీద ఏ రకమైనటువంటి ప్రభావం చూస్తుంది అనేటువంటి విషయాన్ని చెప్పుకుంటూనే, నానో చిప్స్ అనేటువంటివి రాబో కాలంలో రాబోతున్నాయి. ప్రకృతి లోపల అనేక రకాలైనటువంటి కాలుష్యాలను ఈ నానో టెక్నాలజీ ద్వారా అదుపు చేయవచ్చు అనేటువంటి విషయాన్ని చెప్పుకుంటూనే, వారు ప్రధానంగా ఉప్పు నీటిని కూడా మంచినీటిగా మార్చివేసేటువంటి అవకాశం ఈ టెక్నాలజీకి ఉంది. నానో టెక్నాలజీ ద్వారా మనం వాడుకునేటువంటి దుస్తులను కూడా శుభ్రం చేయకుండా, లేదా ఐరన్ చేయకుండా, లేదా విద్యుత్ శక్తి ఉపయోగం లేకుండానే ఆ యొక్క మనం దుస్తులను వాడుకునేటువంటి అవసరం కూడా ఏర్పడుతుంది. నానో టెక్నాలజీ ద్వారా కలర్స్ అనేటువంటి రాబోతున్నాయి, పెయింట్స్ అనేటువంటి వస్తున్నాయి. అవి వివిధ రకాలుగా మార్చుకోవడానికి కూడా, ఆ కలర్స్ కూడా డిఫరెంట్ కలర్స్ కూడా మారడానికి అవకాశాలు ఉంటాయి. ప్రస్తుతం మనం లిథియం బ్యాటరీలు వాడుతున్నాం పెద్ద ఎత్తున. రాబో కాలం లోపల ఈ నానో బ్యాటరీస్ కూడా రాబోతున్నాయి. దానివల్ల కాలుష్యం లాంటివి అనేకం తగ్గిపోతాయి అనేటువంటి విషయాన్ని చాలా స్పష్టంగా చెప్పుకుంటూనే, నానో టెక్నాలజీ వలన కాలుష్యాన్ని నివారణ, ప్రకృతి వనరులను కూడా కాపాడుకోవచ్చు అనేటువంటి విషయాన్ని, చాలా విషయాలు వారు చెప్పుకుంటూనే, నానో కోటింగ్ గ్లాసులు కూడా వస్తున్నాయి. ఇవి సెల్ఫ్ క్లీనింగ్ గ్లాసెస్, అంటే వాటంతట అవే క్లీన్ చేసుకునేటువంటి అవకాశాలు ఉంటాయని చెప్పేసి కూడా చాలా స్పష్టంగా చెప్పుకుంటూనే, నానో టెక్నాలజీ అనేటువంటిది ఆటోమొబైల్ ఇండస్ట్రీలో వాడుతున్నారు ప్రస్తుతం. దాని వల్ల చాలా రకాలైనటువంటి ఉపయోగాలు ఉన్నాయి అనేటువంటి విషయాన్ని చెప్పుకుంటూనే, నానో మెడిసిన్స్, నానో చిప్స్, నానో డ్రగ్స్ వచ్చేసాయి. దీనివల్ల ఎన్నో ఉపయోగాలను చెప్పుకుంటూనే ఇవాళ హోమ్ ప్రెగ్నెన్సీ టెస్ట్ కోసం కూడా ఈ నానో టెక్నాలజీ ద్వారా ఉపయోగాలు ఉన్నాయనేటువంటిది చాలా స్పష్టంగా చెప్పుకుంటూనే నానో టెక్నాలజీ వల్ల క్యాన్సర్ ను కూడా నివారించవచ్చు అనేటువంటి విషయాన్ని ప్రొఫెసర్ ఉదయ భాస్కర్ రెడ్డి గారు చాలా స్పష్టంగా తెలియజేశారు. వారికి మా తెలంగాణ జనవేదిక తరఫున ప్రత్యేకమైనటువంటి ధన్యవాదాలు సార్. మీకు మరొక్కసారి మా తెలంగాణ జనవేదిక తరఫున ప్రత్యేకమైనటువంటి ధన్యవాదాలు తెలియజేసుకుంటూ ఇప్పుడు ప్రొఫెసర్ సుధాకర్ గారు.
Thank you very much, Janavedika and Professor Reddy Garu.
Thank you, sir. Thank you.
Thank you. Asking me to interact in this very highly technical, more scientific lecture, which has been presented in a very simplest manner, because I could be able to see many scientists are there, and I'm not a scientist or not even a science student, but I was very carefully watching as what would be the future of nanotechnology. All through in all your slides, you have been telling about the positive aspect of nanotechnology, but suddenly at the end, maybe on one or two slides, you have projected about the dangers that are associated with nanotechnology. In fact, nanotechnology has come into picture, and I was actually using on the other day the dust-proof, damp-proof Ultima color, and I was wondering, really it is working. Even after 10 days or 15 days, if I touch this wall, nothing is there.
Yes,
But
sir.
I was thinking, what would be the unknown danger? What are the unknown dangers that are associated with this? Which kind of chemicals that might have used, and how these chemicals are going to have its own impact on it? One. And second is that on nanotechnology, you have been talking about the filtration and all that. No, in nanotechnology, filtration, it can filter very minute suspended particles.
Yes, sir.
But my doubt, it's a very silly doubt, is that in case of any solids like water, H2O, we require not H2O, but we want a water, potable water, drinking water, which doesn't contain only H2O, but
Yes,
many
sir.
other minerals and other things.
Yes.
If suspended minerals are being filtrated, maybe it doesn't make any much difference. But if the minerals are dissolved, how could it be filtered? And if
Yes.
it dissolved, and other thing is that if in case of only not only minerals, but also in case of a nano material, if they are dissolved, definitely these nano material, because all these nano material nothing but these the chemicals, inorganic chemicals, all are.
Yes, sir.
There is nothing, all are inorganic chemicals only. And these inorganic chemicals are filtering organic compounds. Now, what are, I do not know much about it, but how could it control? It will work on cancer. As of now, we have not established the fact that which are the cancer growths, how they are operating. In
Sir.
case of heart disease also, which are the contributory factors? Because till yesterday, for the last generation, all that triglycerides and other things are contributory factors. Now it has dismissed. So these are all certain innocent doubts. We can't be.
No, sir. No, sir. It's a very
Thank you.
genuine doubt. Genuine doubt. See,
sir, 1 minute, sir. Please. One another. Professor Padaya garu.
Yeah, right. Bhaskar Reddy, first of all, congratulations. But I just want to add just two things. One is,
welcome, sir. Welcome.
yeah, Dr. Craig Venter, who is one of the leaders who has published the Human Genome Project, is working in creating some cells which will use the carbon dioxide and produce the proteins that we want.
Yes.
So he is actually in advanced stage of actually creating some molecules where it will gobble up all the carbon dioxide that is there and then produce not only proteins, other things. That's one. And another very important thing is, if we really have nano materials, this nano materials can be used to build this thing for hydroelectricity, where because these are now the turbines need a lot of force of these things. But if we use nano materials, even small drop, small force can actually utilized in making electricity. Even from a tap, or even, for example, see, the wind energy. Now we have many fans which can actually rotate from the air of the fan and again, actually make some electricity. So nanomaterials will, in these two things, they can contribute all energies, needs of the whole world. Nanomaterials, only thing is, because nanomaterials are very strong, at the same time, with the little water, this thing, the turbines, we don't need great water resources. Smaller things can actually rotate these turbines and a lot of electricity can be produced. These are some of the things. Of course, a lot of this research is happening, but I think in these two, okay, cancer and all that, anyhow, those things, energy sufficiency can be achieved through these wind, harnessing the wind energy and water energy. Most pure energy. I think, I just want to add this thing. The other things are there. You have completed exhaustively all sources of nanotechnological innovations which will help the humanity. But I think these two things will see the all energy needs of the whole world and most pure green energy.
Yes, sir. Yes. Yes. I think in the coming days also, I think we are going to see several innovations, especially in this nanotechnology area, more in this energy sector, especially. See, your batteries are going to be small. Your output will be more. Efficiency will be more. Your volume will be more. Your efficiency will be more. So that is the way your car size also will be. This is the limiting factor. Right now, the limiting factor to the design of the car is you have to load the batteries into the car. 50% of the space consumed by the batteries and 50% of the weight. It is taken by the batteries and these metals and all these things. If we are going to switch over to the nano batteries, moreover, your car roof, car windows, outer surface, your doors, these things are going to, yes, harness solar energy while traveling also. So these are all their wonders, I think. With the graphene invention, I think we are going to see a lot. And one more thing, carbon dioxide, for example, if we are going to convert carbon from the atmosphere straight away into organic compounds, that means you can circumvent your plant kingdom. You need not rely on the plant kingdom. See, actually, carbon dioxide required to the plant kingdom. This carbon is utilized for the photosynthesis. So, because we don't have any mechanism of harnessing carbon and synthesizing, plants have. But if nanoparticles, if they are capable of capturing carbon and synthesizing the proteins or something like that, yes, this is a wonderful invention. But the thing is, these things are going to compete with the plant kingdom. But anyhow, these are all inventions. I think we have to wait and see. I think, see, our scientific community and the society is also, it is very eager to see the wonders first. The wonders will come to the surface like lightning speed, whereas the blunders will travel at the speed of sound. Later on, they will come. Okay, so I think any.
Yeah, Abidullah.
Sir, thank you, sir. Sir, the nano, how long it will take, sir, for the development of nano?
Sir?
How long it will take for the developments of nano?
Development of?
Nano, micro nano. The wonders when we can see.
Wonders when you can see.
Yeah.
I could not follow, sir.
Wonders when we can see is asking, sir.
Means how long it will take? Means 4 years, 5 years.
How long? See, how long?
Yes.
Very soon, sir. Very soon. Already applications are right now there, sir. See, nearly 2,000 applications, nanotechnological commercial products are there in the market. Everybody knows.
Yes, sir.
This is, you have to appreciate. You have to appreciate even that paint released by those people. Asian paints. Very. It is there. They're passing on that advantage to the society. Damn proof. As a result, the development of the fungi will be stopped. So the indoor pollution, because of the fungal spores and all these things, will be arrested by using that paint. So it is durable, economical, and quality-wise also it is good, sir. That means, see, society is eagerly waiting to just to encash or to enjoy those nanotechnological applications.
Sir.
Thank you.
Your car paints, right now paints are there. Those paints are scratch proof, very hard. I think if give the original paint will last till your last use.
Sir, actually, what I was expecting is the development of nano in the treatment of medicine.
Sir, break. Your voice is breaking, sir.
Sir, I got some headphones here. The development of nano medicine in drugs, which can
drugs.
Be
which disease, sir?
The unknown cells which have been developed in body, which will be developed, are killed by
cancer treatment.
Cancer treatment.
Yeah. I think already, sir, they are in the process of making the nano robots, and they are going to.
Are they in process now at present?
Yes, sir. They are going to be very soon. Right now, in the experimental stage, nano robots are there. They're using them. They're testing them on the clinical trials. I think very soon you will get that treatment, sir.
Abidullah, there is some background disturbance from your side.
Not from my
sir.
side.
Yeah, because the outsiders have got some loud. I have
Okay. Right.
I'm so sorry, sir.
Not at all.
Okay, sir. Thank you. Thank you, sir. Thank you for your interest.
Sir, if anybody has any questions, please raise your hand.
Welcome, Subra. Welcome. Subramaniam.
Yeah, James, go ahead.
Unmute your mic. Unmute your mic. Subramaniam.
Sir, please unmute your mic, sir.
Professor Subramaniam.
Sir is not able to unmute himself, I think.
Unmute. Subramaniam.
Sir, please unmute yourself, sir. Subramaniam garu, please unmute yourself.
Subramaniam garu. No.
Unmute చేసుకోండి, sir. Please unmute. అక్కడ అన్మ్యూట్ అని ఉంటుంది, అక్కడ ప్రెస్ చేయండి ప్లీజ్.
Look at the mic icon. Yes, do.
No, he's not unmuting.
You put it in off condition.
Yes.
Okay.
Sir, James, you have some question? Please go ahead.
Yeah, I have more of a comment than a question. Thank you so much, Professor Uday Bhaskar Reddy. That was an incredible eye-opener and enlightenment for us. We have been hearing about nanotechnology, but did not really have a comprehensive view of it or any kind of an understanding about what it is until this evening, until you have explained to us how it's very wide range of applications, and So I think, of course, as we all know, science will be facing a resource crunch at some point in the near future, and that will have major implications for progress of humanity. And here, as rightfully, nanotechnology is going to fill in that gap. And so, of course, the opportunities are huge. So are the risks also. So these are, I think we have a lot to think about on policy and on lots of issues, because as you have been saying, if such a small particles can invade your body and you won't even know about it. It has major applications. That also has amazing and it's also going to be an amazing time for science also in terms of what can be achieved.
Exactly.
Thank you for giving us a very comprehensive view of this field, introducing us into this subject. And so now we have a absolute understanding. When we read about nanotechnology now, we will have some kind of a foundation, all of us, to have
Absolutely.
Yeah.
Absolutely.
Thank you so much, sir. Thank you so much.
Thank you, James Garu.
Sir, finally, Subramaniam sir has unmuted himself. I request him to say a few words.
Oh, he is successful.
Oscar Reddy, Arctic Congratulations. Nanotechnology, nanotechnology అంటే ఇప్పుడు ఎవరికి తెలిసేది కాదు.
Exactly.
చాలా బాగా చూపించావు. దాన్ని ఫర్దర్ స్టడీ, నాలెడ్జీ ఒక రోజులోనే వచ్చేది. దాని మీద ఫర్దర్ గా స్టడీ చేసుకొని నానో టెక్నాలజీ ప్రయోజనాలని, అన్ని ప్రయోజనాలని స్లైడ్స్ ద్వారా చక్కగా ఎక్స్ప్లెయిన్ చేశావు. ధన్యవాదాలు.
అందుకే కదా వండర్స్ బ్లండర్స్ అన్నది. అందుకే right now we are concentrating on wonders. One day or other, I think we have to talk about blunders.
Manoj Reddy garu, chivarga. Manoj Reddy garu, unmute yourself.
So Professor Vijay Prakash is also there.
Vijay Prakash.
Yeah, Professor Vijay Prakash.
Hello. Vijay Prakash, he is an anthropologist.
Hello.
Hello.
Are you able to hear me?
Yeah, yes, welcome.
Yes.
Yeah, very nice talking. And you have set several examples.
Thank you.
I think
even the primitive man also, in the primitive man, at that period also, cavemen also, they think they have used nanomaterials unknowingly, unwittingly. At that time, they don't know the meaning of the advantage of the nanoparticles. They used this carbon black painting purposes.
Absolutely.
In the caves.
Yes.
That's also nanoproduct.
sir, I am concerned with the society. I am an anthropologist. I look with a different angle. Nano material is not a Brahma Padartha.
Yes.
Will it solve every problem? No. To the best of my knowledge, you have mostly focused on the transportation, fossil fuels, dust attachment, textiles, etc. I set one example. It's only just to enhance our understanding about the nano. You said our clothing, our attires, what we wear, will not get any stain. But what for we are wearing the clothes? Our body odor, our body sweating, all these things should be absorbed by the dress material. If they do not absorb, what will happen to our body? And these are the ticklish issues lying behind the nanotechnological advancements. In that way, most of your talk is talked about, presenting about latest technologies that are used by a very, very elite section of the society. We are mostly concerned with the food. Food that we are consuming is so polluted now. We are very much suspicious when we are taking food into our mouth. And those are the concerns that the scientists should address it. Because no doubt, the cancer, treating the malaria, treating the diseases, they are also as important as But to empower the nanotechnology, every mouth should be fed every day twice. And what type of food that we are consuming now? And why, if the nanotechnology is utilized in the food, that means we are consuming nanotechnology every day into our mouth. And what would be the evolutionary process of our biology, our metabolic activity, and how to get out of this technology? Whatever the technological advancement that we had in the historic past, and we are facing the music of it. Again, another technological wave is coming and knocking our door. What for wonders or for, at the question mark you have put at your last slide. And that question mark need to be answered as an anthropologist myself from my side, and as an environmental scientist from your side. Thus, the nanotechnology will give solutions to the problems that we have been facing today. In what way nanotechnology, definitely it is creating wonders, but every wonder behind, and there is some disaster. You are mostly talking about the batteries. And from where, what are the materials used in the battery? Where do we throw after use? And what is the recycling process? What would be their density in terms of molecules and in terms of other nanomaterials? And these are the things that need to be addressed with a different angle. Whatever you have presented is definitely you are glorifying the nanotechnology. No doubt about it, there is glory in it. But every development, every initiative in technological advancement initially is glorified and subsequently is subjected to criticism. That would be the food of us as scientists. So as in terms of social or in terms of societal or in terms of social sciences, my worry is that we are facing a different technological adversities in the years to come. And scientists, particularly like you and me, particularly in the sense we are not directly concerned with the chemistry or with the pharmacy, etc., but we are concerned broadly with the macro level environment and macro level human societies. So we can interact in such a way that we address the issues with a social mosaic than with a molecular mosaic or a nanotechnology mosaic. These are my impressions, professional impressions. Personally, as Uday Bhaskar Reddy, I appreciate you for your vast presentation and with all setting examples of what wonders that the humanity can face in the years to come. At the same time, we have to look back. What would be hidden behind in an alarming situation also need to be presented. You have presented, but you have cut short into 3-4 slides about the adversaries of the nanotechnology. But the technological advancements must address, must empower in terms of the society. And these are my some reflections on your talk. It is really wonderful, and you have driven all of us into nano level to understand the wonders. But at the same time, in the years to come, we have, as scientists, we have to answer the adversaries or the negatives, or I think the word that you have used is wonders and the other one, blunders. So what we are doing is a blunder, or it is going to be a wonder, need to be answered. It needs to be generally what happens in human psycho, virtues are adopted later than the vices. So that any new technology is considered initially by a scientist as a vices. That is the reason we take in terms of limitations. And what are the limitations of the nanotechnology? And need to be understood in a different mold. At this, we do accept every science brings the best for the human society to flourish and continue. But the changes are so rapid. Our genomic material is not in a position to absorb, to make sustainable. But that that what we call, I think Padaya may explain in different way, in a more scientific way, the epigenome. That means whatever the changes that, Nana?
I am about to answer your questions.
Yeah. No, it's not question. It's not question. It's only we are concerned with society. We are concerned with society.
You are very much your concerns are very, very real.
Yeah,
The
suppose for
answers
example,
the
most of the
answers-
examples have
Right,
gone
right.
around the
That's why.
motor
Just-
car.
Yeah,
And
just
the motor
listen.
car, color changing, battery,
Right, right.
windscreen. Yeah, these are the things. Yes, they do show as an exotic side of the human
Right.
society.
But in a
But-
neoliberal world, these are the things
Yeah.
that are counting, sir.
Yeah, no.
Yes, sir. Yes.
The perfect answers for your concerns will come from biotechnology and genetic engineering.
Yeah, that is what
These-
bio
these
nano
things,
info.
Biotechnology and genetic engineering will,
Yeah.
will improve the
Yeah.
economic status of the whole world multiple times.
That's what I'm. No.
Two important things. It will
No, no, my friend Padaya,
Food that we
listen to
need,
me. Listen to
and
me.
also
Bio, info, nano. These three combinations,
Yeah.
biological thing, information, and at nano level, and they are blended into one, and there would be a wonderful, no doubt about it, wonder. But behind every wonder, there would be something that we have to concern as social scientists. As social scientists, not as a lab scientist. I'm talking about not as a lab scientist.
yeah, science is always neutral. How
Yeah.
this is used to the society, who actually uses this thing to the society is very important.
Yeah,
And
that's what my concern.
That will be taken care of by
Yeah,
genetic engineering and biotechnology, because you can produce multiple times of the food, the best food that is now possible, and the health. These are the most important two things: your food sufficiency and health. These will be taken care of by biotechnology and genetic engineering.
yeah.
Because
At the same time, let me complete. At the same time, n number of patayas also can be produced.
of course, yeah, there is always that, yeah, right.
Okay,
N number
okay.
of patayas
Oh yeah.
can also be produced.
Wait,
No,
wait,
these are in a lighter vein. I am having a dialogue among the audience that Uday Bhaskar Reddy is a born scientist, and he knows, and he takes very the smaller examples, bringing them into the scientific fold, and explains in a very categorical way the way how science need to be interpreted in day-to-day activities. The other day, once I attended to his lecture where gene patents and the consequences he had clearly explained. So those are the things that really matter in terms of environmental science and in the years to come. Because what we are wondering is, and most of the arable land is going to be disastrously reduced due to the climate change and meltwaters of the glaciers, rising of the sea level, sea transgression, and these are the concerns. And the nanotechnology definitely will address such type of mega issues to solve in a short span of time for the well-being of the human society as a whole. Thank you very much for having given me an opportunity to interact with you. I congratulate once again. I congratulate the Telangana Jana. Really, it is doing an excellent exercise every week. I think maybe others are missing, but the organizers are so patiently, they have been making this a platform accessible to the like-minded people. Anyway, I congratulate you, sir, and
Thank
also
you.
very special thanks to Uday Bhaskar Reddy for he had presented the presentation in an exponential way. Exposure is very good, and we learned many things from him. Thank you.
Thank you,
Last, Manoj Reddy, we are running short of time. We are running short of time.
Yeah, good evening all, and ముందుగా గురుగారు పురుషోత్తమరావు గారికి నమస్కారాలు తెలుపుకుంటూ సార్ థ్యాంక్ యూ ప్రొఫెసర్ రెడ్డి గారు for your wonderful session really. At the same way, thanks to Professor Peddaya garu and Professor Vijay Prakash garu and Professor Subramanyam garu also for a wonderful debate today on nanotechnology, and thank you so much, Ramana.
Just 1 minute only. See, in the 1930s, early 1930s, our scientists invented CFCs, chlorofluorocarbons. And at that time, they were proclaimed as wonder chemicals and miracle substances. Really, they are wonder chemicals. They have served the society for 40 years in various sectors, food packaging sector and electronic sector, and see what not. Even these deodorants and several things, even your cushions, foam beds, and all things. After 40 years, our scientists could able to see the negative phase of the chlorofluorocarbons, especially in the biosphere, troposphere. Chlorofluorocarbons are perfectly 100% they are safe. They won't react with any element of the periodic table. They won't react. They won't contaminate your water. They won't spoil your air. They won't spoil your food. So they are 100% they are safe in the troposphere and biosphere. Once they leave this troposphere and enter into the stratosphere, then only they start damaging the ozonosphere, which is a protective layer to the life here. So it took nearly 40 years to see the negative phase. Now we have banned those chemicals. So this type of situation is there with any technology. Moreover, this nanotechnology, it is not a single subject. It is an multidisciplinary. See, biotechnology, it involves only few branches, whereas nanotechnology, it includes physics, chemistry, everything, all branches, engineering, medicine, all branches together, we call it as a nanotechnology. And moreover, our scientists they are relentlessly, they are doing research and they will go on, it goes on, it won't stop. It is a dynamic process. The problems will be coming and they will be showing solutions, and it is a continuous process. So I think the anthropologists, I think they need not worry much about I think they have to keep some confidence over the scientific community. Okay, definitely scientific community is going to show answers. Right now, among these technologies, nanotechnology, it is going to, yes, be lucrative. It is going to show address some of the important problems, issues of the planet. Okay. Thank you very much, sir.
Thank you, sir.
Sir, Professor, sir. Hello.
Sir.
Hello. Hello. Sir, am I audible?
Yeah, sir, please go ahead.
Hello.
Audible, sir. Audible.
Hello.
Yeah, you are audible, Abdullah. Please go ahead.
Sir,
Professor, sir, I'm really grateful and thankful to you. I just need for the clarification of one small question.
Sure, right,
With this nanotechnology, sir, with this nanotechnology, in future, a man can stand young forever and ever. Will it be possible?
Sir, no. Sir, that is why I told you, sir. Today's sense may become tomorrow's nonsense. And at the same time, today's nonsense may become tomorrow's nuisance. So forever it cannot be taken granted, sir.
Sir, my question is nonsense.
Tomorrow, if some other technology,
my question is nonsense.
Some other technology may come and replace nanotechnology.
Yeah, thank you, sir.
Yeah, definitely, day-to-day changes will be coming. Day-to-day changes will be coming. But according to your
I think we should close this.
Thank you, sir. Thank you very much.
Sir, thank you very much, sir. Thank you.
Telangana Jana Vedika online meeting వచ్చేసి కీలక ఉపన్యాసం ఇచ్చినటువంటి ప్రొఫెసర్ ఉదయ భాస్కర్ రెడ్డి గారికి మా తెలంగాణ జన వేదిక తరఫున ప్రత్యేకమైనటువంటి ధన్యవాదాలు సార్. అదే విధంగా ఈ కార్యక్రమంలో పాల్గొన్నటువంటి ప్రొఫెసర్ సుధాకర్ గారికి, ప్రొఫెసర్ పంజయ్ గారికి, ప్రొఫెసర్ డాక్టర్ జీవన్ గారికి, ప్రొఫెసర్ సుబ్రహ్మణ్యం గారికి, ప్రొఫెసర్ విజయప్రకాష్ గారికి, మనోజ్ రెడ్డి గారికి, ఇతర సభ్యులందరికీ, వేదిక సభ్యులందరికీ పేరు పేరున ధన్యవాదాలు తెలియజేసుకుంటూ ఈనాటి ఈ యొక్క అంశం ఇంతటితో ముగుస్తుంది. వచ్చే ఆదివారం మరొక అంశంతో కలుసుకుంటామని తెలియజేస్తూ అందరికీ మరొకసారి నా యొక్క ధన్యవాదాలు, నమస్కారాలు తెలియజేస్తున్నాను.